Welcome to my YouTube channel. Today in this video we will learn about smoke testing, sanity testing and retesting. Let's start with smoke testing. Smoke testing is also known as build verification testing or confidence testing. Is a type of software testing that checks whether the deployed build is stable enough for more rigorous testing. It is typically performed after a new build is deployed to the environment, such as test or staging environment, to ensure that critical functionality work correctly without conducting exhaustive testing. What is the objective of smoke testing? The main objective of smoke testing is to determine whether the critical functionality of the software work as expected and whether the build is stable enough for further testing. Scope: smoke testing focus on the most critical and basic functionalities of the software. It does not aim to test all features comprehensively but rather to verify that the essential features are working as intended. What is the process of smoke testing? The selection of test cases. The selection of test cases is very important for smoke testing. Test cases for smoke testing are selected based on the critical functionality of the software. They are typically high level and cover the most important workflows. Then next, execution. The selected test cases are executed against the newly deployed build. Then verification. Verification: the most result of the test cases are verified to determine whether the build passes or fails the smoke test. Then last is decision. Based on the result, a decision is made whether the build is stable enough for further testing. If the build passes the smoke test, it is considered good and can proceed to more thorough testing. If it fails, it indicates that there are critical issues that need to be addressed before further testing can be conducted. So here in the diagram we can see there are the initial build 1 2 3 and it can be number of n. Then when the initial build is deployed to the test environment, first of all we will be performing smoke testing. In smoke testing, if we find any bug, then this build is rejected or smoke test fail, so this can't be going for the further testing. If this smoke test pass, then we can go for the further testing like functional testing, system testing and performance testing. Likewise we can perform. The next is advantage of smoke testing. It detects critical issue early. Smoke testing help in identify critical issue in the software early in the development process, as we have seen just now. Saves time and efforts. By quickly identifying whether a build is stable, smoke testing saves time, effort that would otherwise be spent on more extensive testing. Improve overall quality. By ensuring that basic functionality work as intended, smoke testing contributes to overall quality of the software. And what are the limitations of smoke testing? Smoke testing does not cover all the feature of the software, as we will be only testing the critical feature in the beginning, so it may miss issues that are not related to critical functionalities. It does not replace thorough testing such as regression testing or functional testing, which are needed to ensure the overall quality of the software. Next we will be going for a sanity testing. It also known as sanity check or build verification testing, is a type of software testing that is performed to quickly evaluate whether the new functionality or bug fixes introduced in build are working as expected and whether the build is stable enough for further or more testing. The main objective of sanity testing is to verify that specific functionality or areas of the software that were modified are working correctly without conducting exhaustive testing. Sanity testing focus on specific functionality or area of the software that have been changed or updated. It does not aim to test all features but rather to quickly verify that the changes made have not introduced any major issues. The process of sanity testing is, first we will be selecting the test cases, then software that have been modified or updated. The selected test cases are executed against the build to verify that the specific functionality or area work as expected. The result of the test cases are verified to determine whether the build passes or fail the sanity test. Based on the result, a decision is made whether the build is stable enough for further testing. If the build passes the sanity testing, it is considered sanely built and can proceed to more thorough testing. If it fails, it indicates there are a critical issue that need to be addressed before further testing. Next is advantage. Early detection of issues. Sanity testing helps to quickly identify any major issue introduced in the software due to recent changes or update. Since sanity testing focus on specific area of the software, it can be performed quickly, saving time and effort. By verifying that recent changes or updates work as expected, sanity testing contribute to the overall quality of the software. As there are some limitations also, that sanity testing does not cover all the feature of the software, so it may miss issues that are not related to the specific area being tested. It does not replace thorough testing such as regression testing, functional testing, which are needed to ensure overall quality of the software. Next is retesting. Retesting is the process of verifying that a software specific bug or a issue reported earlier has been successfully fixed. It ensures that the fix is effective and does not introduce new issue, helping maintain the overall quality of the software. The main objective is to verify that the bug or issue has been fixed as intended by the developer. It also aims to confirm that the fix has not caused any new problem or regression in the software. Retesting is typically performed after developers have implemented a fix for a reported bug and the fix has been integrated into the software build. It is an important step before releasing the software to ensure that the reported issue has been resolved. Identify the bug, then start by referring to the original bug report that described the issue. Reproduce the bug. Attempt to reproduce the bug using the step provided in the bug report. Verify that fix has been correctly applied to the software build. Repeat the step that originally caused the bug to verify it no longer occurs. Ensure that bug has no longer occurs and that the fix has not caused new issue. Record the result on the retesting, including whether the bug was successfully fixed and any new issue that were identified. There may be some challenges we can face while retesting, that is we will get a limited time to retest all fixed bugs in each software build. There will be some risk of introducing new bugs while fixing existing one, and effective communication between developer and tester is crucial for successful retesting. So we should have a best practice for retesting is priority. Priority bug based on severity and impact to focus testing effort effectively. Use automated testing tool to speed up and retesting process and increase test coverage. Collaborate closely with the developer to understand the fix and verify its effectiveness. So this is all about retesting. Then we can see the difference between retesting and sanity testing in the below diagram. Here in the this is about retesting. There is a earlier build that corrected in the respective error test case. So there could be any bug that can be correction, or there will be bug fixes. Then after bug fixing there is a new build that is called current build. After current build there is some fixes for a particular bug, then that will be in the retesting. So tester will retest this, whether it retest got pass, then test case is pass, it failed, then test case is failed. So this is called retesting workflow. But in sanity testing there is one stable build that is already stable. There we are going to check in any module some sanity testing we will perform. If sanity testing pass, then it will pass the build. If it fails, then we will reject the build. Likewise, there is a difference between smoke test and sanity testing. Initial build when the software is relatively unstable. Here the build is unstable, there could be any number of build. Then we will be performing a smoke testing to verify critical functionality like application starts successfully. Like basic example we can see if login works properly or not for any particular application. If this test case is passed, then yes, then we can go for the any other testings. But in the form of sanity testing, relatively stable build. Here it is unstable build, here it is stable build after multiple round of regression tests. There could be any number of build. Here we can see these are initial build, there is increased number of build. So verify new functionality bug fixes in the build, that we will call as sanity testing. If this sanity test is passed, then we can go for the further testing. So this is very important topic, difference between smoke testing, sanity testing and retesting. So first we will see the as what is the purpose of these three. The purpose of smoke testing is to quickly determine whether the critical function of the software are working. It helps to identify major issue that could prevent further testing. Sanity testing is performed to ensure that a specific new feature or bug fixes are working as intended. It focuses on recent changes to the software. Retesting is done to verify the specific bug or issue that was previously identified and reported has been successfully fixed. It ensures that the fix is effective and does not introduce new issue. The objective of the smoke testing is to verify overall stability of the system and determine if it is ready for more rigorous testing. The objective of sanity testing is to verify that a specific area of the software that have been modified are working correctly without conducting exhaustive testing. The objective of retesting is to confirm that a specific bug or issue has been fixed and that fix is effective. Smoke testing can be performed by developer or tester depending on the organization testing practices. Sanity testing is typically performed by testers who have a good understanding of the recent changes made to the software. Retesting is usually performed by the tester who are familiar with the specific bug or issue being retested. Smoke testing tests the entire system to ensure the critical function works. Sanity testing focuses on a specific component or functionality that have been modified or updated. Retesting focuses on the testing the specific bug or issue that was previously reported. Smoke testing provides broad coverage of critical function to ensure system stability. Sanity testing provides focused coverage on recent changes or additional to the software. Retesting provides specific coverage of a bug or issue being reported. Smoke testing is usually documented or scripted with the predefined set of test data. Sanity testing is usually not documented and often performed in an ad hoc manner. Retesting may or may not documented depending on the organization testing practices. Smoke testing is considered a subset of a acceptance testing. Sanity testing is a subset of regression testing which involve verifying the recent changes to the software have not affected existing functionality. Retesting is the subset of regression testing. It involves retesting a specific bug or issue after a change has been made. Smoke testing is like a general health checkup where a doctor checks basic health indicator to ensure overall wellness. Sanity testing is like a specialized health checkup where a doctor focuses on a specific area or organ based on the result health concern or changes. Retesting is like a follow up checkup where a doctor verifies that specific health issue has been successfully treated and resolved. In summary, smoke testing, sanity testing, and retesting are all important aspects of software testing process. Each serving a specific purpose in ensuring the quality and stability of the software. So that's all in this video. Thanks for watching.